Good? Wednesday?
Good.
All right. I'm Collier. I'm a machine learning engineer. I work at Cloudflare. I'm going to talk about deep agents. This is the second talk I've done here on deep agents. Last time I went over kind of like the high level, what is deep agents, how does it work. I'm not going to go that deep into the weeds this time. I'm just going to show you an example of using it. And I'm going to give you like an honest appraisal of my experience using it and what I like and what I don't like. But first of all, this is what deep agents from the LangGraph or the LangChain docs says when to use deep agents. So use it when you need to handle complex multi-step tasks that require planning and decomposition, manage large amounts of context, delegate work, persist memory. So why would you not just use LangGraph for that? Well, the short answer is you still can use LangGraph for stuff like this, but this is fundamentally a different like paradigm of agentic workflows that is built on basically after what Claude Code came up with their planning and task decomposition, context management, subagents, and long-term memory. They basically took what they thought was the best attributes of Claude Code and built it into this library. And then just a reminder, it fits in with LangChain and LangGraph. And deep agents can be deployed, yeah, anyway. So, okay, so I wanted a use case and I wanted to see like, can deep agents do deep research? And they're not the same thing. Deep research, I'm sure some of you have used. You basically ask an LLM a question, it takes a while, it goes through a bunch of stuff, it comes back with an answer. It goes through tons of context to figure out what the like best answer is for you. I wanted to do something similar. So I came up with a mini project to work on. Did anyone watch the NVIDIA keynote last week from Jensen? It's okay, it's not, anyway, he gave a talk about a lot of stuff. He talked for like an hour and a half. So what I wanted to do is I wanted to see if I could take the learnings from his talk and try to find interesting companies out there that are doing what he's talking about. So what he talked about in his talk was a bunch of stuff, and this is a meme, but basically he's the merchant of the infinite money merchant. Yeah, Jensen's amazing. Anyway, so the themes he came up with in his talk were the dawn of a new computing era, and this is, by the way, as a result of the deep research, deep agent process. He also came up with AI factories, that's another theme, physical AI and robotics, and then some trends, the end of Moore's law, accelerated computing, the virtual cycle of generative AI, digital twins and simulation. By the way, I don't know what all these things mean, but if any of you do, then maybe we can talk later. But anyway, I basically started the process getting this, and the goal was to take these themes from his talk and then go through a list of about 400 tech companies and look at their company descriptions and say, do any of these companies match up with the themes that he's talking about? Do any of these companies fall into those themes? And then if they do, take the top 100 and go through each of the press releases for those companies and see, do the press releases make the case even more that they fall into this theme or not? If not, then it doesn't move the needle. But this is a useful exercise to see like, hey, what companies are out there doing the things that he's talking about, these cutting edge things in this new world of AI and computing. And so this is my deep research use case. So there's a few ways I could start talking about this. I think probably, I can either show the results first or I could show the code and stuff first. I think I'll show the results first. So I showed already, basically the results of the first part of the process, which is getting the themes, and then I'll show the final result, which was this list of companies, and this is what the deep research came up with. It says, analyzed all these themes, validated 87 of the 100 matched companies with press releases, and then here are the rankings of all the companies. And basically the highest rank that it started with was 10, but then you tack on the press release stuff, and it can go, basically you can have a final score higher than 10. So anyway, we had like everything from Microsoft, NVIDIA, no surprise, to Astera Labs and CoreWeave, and it just goes down and down, and the lower you go, the less these companies may match one of these themes. But anyway, this is like the final result, so I'm kind of showing you the end first. So what was the experience like to get this? This is like a ton of content, right? It's 244 pages of content. So clearly, I think this falls in like the deep research type of use case. So let's show the code really quick. Let's show like how this works. Can I zoom in? Because that's really small, right? Yeah. Let me just do this really quick. Make it bigger. Let's do like font of like 18 or something. Huh, that didn't work. Okay. Wow, okay, that's surprising. Well, okay, well, let's skip the read. I mean, the README is whatever. So anyway, deep agents looks like this with the code. You basically create an agent with this create deep agent function, and then you give it tools if you want to, a model. The model I used was Google Gemini for this. I found that it was a little faster than Claude Code, or sorry, Sonnet 4.5. So yeah, that's what I used. And I basically, you start out, you give it a system prompt, and in this pipeline, I'm saying there's 4 sub-agents. So one of the sub-agents does the transcription. It goes through the transcript, finds those themes that I showed you before. The second one goes through all the companies, finds the descriptions, and then matches them against the themes. And then the third sub-agent goes through all the press releases, finds those for each company, and says, does this back up the claim that this company falls in this theme? And then the final agent like ranks all the results and gives you the top 100. So like four sub-agents, and this is what the sub-agents look like. So there's these 4 right here. And the way this works is you would just go define any of these sub-agents as a Lang chain agent, which is new, which is what Colin was talking about earlier. So you would do, from Lang chain import, from Lang chain agents import create agent, and then you would start just making sub-agents. So the first sub-agent, I just mentioned, goes through the transcript. It has a system prompt. This basically just tells it what it needs to do. I gave it this, so we haven't talked about middleware, but Colin talked about it a little bit. It's, this is new, and it's really powerful, and it's basically ways of giving your agent to do stuff before it does things or after it does things. And it's super useful. So I gave it this S3 system middleware so that it could write to stuff on S3, in this case R2, Cloudflare. So it could read and write files from there. I used this kind of remote bucket as a place to put all the files. That makes sense if you're running stuff in production or running stuff in any like serious manner. You usually want remote file storage or remote database or whatever. The second middleware was content truncation. Didn't really matter for Gemini because the context window is so big, but for some LLMs, you want to truncate the content so it can fit in context window. And then logging. Logging does not come out of the box with deep agents. You'll have to add your own middleware. And so I added this one. And by the way, this is all be on GitHub if you want to take a look at it, copy it, whatever. But what I found is if you start running a deep agent process, it can take a really long time. And if you don't have logs, you're going to be like, what is going on? I'm just going to give up on this. So the logging middleware is super important. The second sub-agent, company matcher, goes through goes through all the, companies, looks at the descriptions like I already mentioned, and it writes the results to S3, R2. And then the third one goes through and does this validation process. So end up getting like batches of companies to start with. Looks like, this, so this would be like a list of companies to go through. And then the next one would go through each company and find the key evidence, that's the PRs that back up the claim that it's in this theme. And so these are, links to press releases. And you get a original score, like, hey, this company, Adobe, falls in these themes. And it has a kind of a weak score of 6. But then we went through these PRs, and we adjusted the score up by 1, so now it's 7. So that's what the validation agent did. And then the last agent just combines all of these files over here and gives you a final ranking with all the companies. And that's kind of what I showed in that Google Doc earlier. So yeah, I mean, it's just kind of reading and writing stuff to R2, S3. Talk a little bit about just some like the experience of doing this. So I found that it's kind of hard to keep it on track and like have one agent do one thing, the next one do the next thing, and like expect everything to be seamless. So I found that I encountered stuff like schemas would be written wrong. It would in my model file, I say, hey, you need to write the file like this, and it would write it like with like a slightly different key or something like that. Or things like, hey, I need you to loop through all 100 of these companies. This is in your system prompt. I want you to do that. And it would loop through like the first 10 and then be like, oh, I did enough. I'm good. You're good. And it's because these LLMs are fine-tuned to save tokens. So they will just naturally kind of take shortcuts. Even the good ones like Google Gemini or Claude, they'll do this. And so you have to be very explicit and like super clear in your prompts what you're telling the DP agent to do, because it will deviate, and the weaker your prompt with the more gaps in it to fill, like it will just take shortcuts. So that was kind of like an unfortunate thing. And I think everyone's seen that as used any of these planning agents like Claude Code or anything. Like you do have to keep it on the rails, and this is the same thing. So basically putting the schemas in the prompt, just like printing it out, and also putting examples of like an example in the prompt as well is a good idea. Like here's how the schema should look when you actually fill it out, not just the field names and stuff and field types. And so the prompts, that's one thing that's really important. Second thing is you can actually use the middleware to keep it on track too, which is really nice. So all of this middleware has this agent middleware here, this class. They all have this after tool call hook here, and then before tool call hook. So what you can do is you can make it check stuff after it runs a tool call or an inference or whatever, and you can have some check there. And so if it fails the check, then you can yell at it, basically. So here's an example where it's like the number of matches in the company matcher doesn't match what the expected one it was, and this happens before the tool call. So in this case, if this failed, all of this would get printed back to the agent, and the agent would actually see this error message and correct, because it sees, oh, I'm about to call this tool, but this before tool call failed, and now I'm getting yelled at. And now I see in the code why I'm getting yelled at, so I can go fix what I was just about to do before I call a tool, and then call the tool the right way. And so it gets very meta, where you're kind of like almost letting it, it's like having a toddler or something, you're letting it kind of fall down and be like, well, now you know not to do that. And it's kind of, it's a little metaphysical in that way. You're kind of giving it, you're giving the error messages back to it, just like you would when you're using Claude Code or you're vibe coding or whatever, you're like, hey, this failed, here's the error. You're doing it now in your program, like at runtime, and it's course correcting from that as it's executing, which is kind of a weird thing to think about doing, but that's how this works. And so I found that between the middleware and designing the tool calls in the right way that like really nailed down how to do things, you basically just yell at the agent a bunch and it does things right. And if you don't do that, it'll deviate and get off course and do things wrong. So that's just a experience I encountered. So how long did this take to run and how much did it cost? So this is Langsmith. This is how long it took to run. It took, and this is a huge job. You know, it has to run through a transcript, 400 companies, and validate each one against a bunch of PRs. It's a lot of work, but this is how long it took. I started last night at 12:38 a.m., and it finished while I was asleep at about 4 a.m. So, you know, it took a long time. It burned about 11 million tokens, and it cost, I'm just seeing this actual cost for the first time. It burned, you know, about $80, which is like, wow, that's a lot. You know, I don't know how that compares if I'd run this with like Sonnet 4.5 or Opus or something like that. If anyone else wants to test, please. Anyway, so it is expensive and it is very token intensive, and this kind of goes back to, you know, as I'm testing this stuff, could I have just done this in LangGraph and gotten it way faster, way less tokens, way cheaper? And the answer is definitely yes for this use case. But it wouldn't have been the same type of agentic workflow. I wouldn't have been like letting it make decisions and stuff like that. And so it was, for this use case, this is pretty deterministic. A lot of use cases like this are not. Like this may not even be a real open-ended deep research use case. So in some cases, you definitely want to give it more leeway to go figure things out and do stuff. In this case, this is kind of specific. It was like, hey, one agent, next agent, result. So it's up to you to determine if your use case is suitable for deep agents or not. Not all of them would be, but I thought this is at least a good learning experience. This also makes me want to have like my own hardware to run stuff on. Yes?
When you say that you can run much faster, I know this is not perfect use case, but how much faster you can run?
Well, I mean, with LangGraph, you're not letting it figure stuff out. You're just telling it what to do. It's like very deterministic. So when Deep Agents runs, just like Claude Code or anything like that, you see it kind of thinking and figuring out, hey, I need to do this next. I have a to-do list. I'm going through the to-dos. Oh, I didn't do that to-do right. I need to go back and finish it because that's part of the middleware is yelling at me now. So that kind of whole like 2 steps forward, 1 step back type thing, it does spend more tokens. It does take longer. Whereas LangGraph just straight through.
So you're saying that maybe in a document, and working on the document, you didn't just follow. Like when you say it in the plan, I mean,
yeah.
One single question, still with a plan,
Well, let me show you the log. So I did send the log to S3, and I can show you kind of how it thinks when it's running. So here's the log, and so this is when it just starts out. So it's using this write to-dos tool, and so it's actually writing down the to-dos it needs to do. So the first to-do is call the transcript analyzer agent to analyze the transcript file. The second one, call a company matcher sub-agent to match companies from the themes, analysis JSON, et cetera. And then there's a couple more agents. And then as you keep going, you can see it completed the first to-do, and now the second one's in progress. And then as you keep going more, it completes the, if I can, this will take a little minute, but let me just write to-dos. Yeah, anyway, so then it completed the second one, and eventually it gets through all its to-dos and it's done. But you can kind of see the timestamps going by on the left. It's like, you know, minute by minute. So it's thinking as it's going. It's like, hey, I just did this.
That's really cool. It's actually writing files.
Yeah.
So like as a, you were talking about us having trouble, say, staying on track with going through like every company file. Is there a way to just add in some tool to do like a for loop of all the files that it generates?
So you could do a tool that you just call it and wait for it to finish, and it could do another LM invocation or something like that. That kind of gets back into like, hey, should this be LangGraph instead? Whereas this is like, hey, I'm telling you what I want you to do, just go do it, and here's the things to hopefully keep you on track, the middleware, checking if you're off, if you skipped a ticker or whatever. Yeah.
So if you call a tool, I'm just thinking usually for this kind of stuff, use entropy protocol, MCP protocol. I mean, is this connected to MCP?
It could, yeah, you can definitely connect this to MCP. Yeah.
So, but is it out of the box? Or you have to
It actually, in their docs, I think it's on the README of the repo. Yeah, I mean, it's definitely out of the box. It's like very, yeah. So anyway, I mean, it was a fun experiment. I think I will use this for some use cases. Some things it may not make sense financially or from a time perspective, but it's really powerful stuff. I'm just getting started playing with it. It's, you can do a lot with this. The first use case I showed was more open-ended. It was just like synthesizing two data sets together and like coming up with a report. And that worked really well. It ran in like a minute or two, and it created, like a 500-word report for me. I'm still happy with the content that it came out with here. I mean, I had to pay a human to do this would probably cost a lot. So if anyone wants to buy this, I'm just kidding. I'll just give it away for free. Yeah, we could, no, it's free. If you're looking for good investment research, and you actually know about these companies, I'd be curious because you could tell me, is it BS or not? That might help. So.
What did you use for the first part where you took the NVIDIA talk? Did you like drop a transcript and then run it through something?
That's all part of the agent. That's the first sub-agent here. It's just goes through the transcript and the prompt's right here. I mean, it's pretty open-ended prompt too. It just says, read this file in S3, analyze it to identify themes, trends, focus areas, write the analysis. And so even that like very open-ended task, produced basically this whole document here. Yeah.
You're getting the data right there. So I missed the part where how do you get the data from?
Oh, I already had all this data. I'm a stock market nerd, so I already have all this stuff. I'm happy to share it if you want. If anyone else wants to do this. Of course. Yeah. Again, tokens. If you want to spend the tokens, you can make it do whatever you want. You can have it go search and pull stuff. The quality may be something you want to verify and lock down a little bit. The data in there, I'm pretty happy with the quality, so I was ready to just turn it over. But yeah, it's all about data. Everything comes back to data. Do you have it? Do you trust it? So yeah.
You're mentioning one of the bigger problems you had was with it not adhering to the schema and the whole YAML part, right? It was like straight back to doing running. Did you try using structured outputs at all?
I did. That was the first thing I tried. I think there's some kind of, this may be a skill issue or just me not figuring it out, but there was some hitch there with deep agents and structured output that like was a blocker. Like something, maybe it was to do with the middleware or something like that. It's probably on me, but most of the time when you use structured output, it's through one LLM call. It's like one LLM call, structured output, and it's not a tool call. It's like the LLM, it's like an AI generating a response in a format. This is like hundreds of LLM calls. So it's kind of like, where do you even put the structured output for the LLM to use? Because it's like making so many calls that you kind of have to force it just to use a tool if you want a structured output. And that's mostly what I did. So for like a lot of the stuff, there is tool outputs, but when it comes to like combining all of these validation files, for example, and re-ranking them, that is like, do you really want to write a tool for that, or you just want to let it do that? And then if it screws that up, can you yell at it through the middleware after it did it, before it goes to the next step, to then have it be like, oh, I just did that wrong, let me go back and do it again. So it's kind of like, there's no right answers. Like you could you'd force it to use a bunch of tools, or you could have it get checked after it does, every step, and then goes on to the next step with the middleware. It's a little unclear to me actually, like what the best approach is, but I found that for my use case, it was skipping a bunch of stuff until I added these middleware checks, and then it stopped, and then it was like back on track because I kept yelling at it when it would, skip, and it'd be like, oh, I just skipped a ticker, I need to go back. So it's kind of a bad answer, I'm sorry. Yeah.
For the middleware checks, were you using another agent to check the output?
Nope. It's all like it's all self-encapsulated. So for example, the one I was just talking about, the validation one, down here. So this is the data model it's supposed to write out. It looks like this. The results should come out looking like that. And so I'm telling that in the prompt. And I'm telling it, not basically, these are the things you're forbidden. You can't query the same company twice. You can't skip companies in the list. Telling it very specifically, don't skip anything, don't take a shortcut, anything like that. And then the middleware part is there to keep it on track. So this validation file tracker middleware tracks when validation files are written, and then basically after the tool call runs, it checks and makes sure that like, hey, we actually have a file written out that is the one that you just said you wrote. And if it's not there, then we have an issue basically. So yeah, a little bit of trial and error, and I'll be honest, Claude wrote a lot of this, and I was just like, is it gonna work? Yes, okay, great. So it took some trial and error, and it's definitely worth thinking about, but the middleware is, I think that's my biggest takeaway, is it's super powerful, and it'll really keep these things on track if you design it well, and you basically have it like block the LLM from continuing, or the agent from continuing, because you set up the middleware correctly.
I mean, so I know that what you said, that it's actually a single chat, so to speak. Will the middleware be injected every single time, or is it just an addition?
So it's for the whole subagent. You set up, you just have this middleware, whatever you want to give it. You don't have to give it any middleware if you don't want to. I gave it all this stuff so that I make sure every agent logs with the logging middleware. I gave it this content truncation thing, just in case it ran over the context window, it would truncate, so it didn't run into context overflow issues. I gave it that file validation tracking middleware, and I gave it S3 middleware so it would be able to access stuff on S3. So we could probably do a whole talk on just middleware. Anyway, thank you so much. Appreciate it.